Hey everyone, welcome back to AI Tech Hub. I'm Cody. So, if you're ready to untangle what is honestly one of the most hotly debated topics in modern software development, well, you are definitely in the right place. Today, we're settling the score, or actually, scratch that. We're explaining the differences in the great battle of REST versus GraphQL. We're going to break down these two heavyweights of API architecture, figure out exactly how they tick, and most importantly, figure out why you'd actually choose one over the other for your next big project. Let's get right into it. If you've spent any time looking at job postings for developers, engineers, or even tech product managers lately, you've definitely seen these buzzwords staring right back at you. Companies are always asking for RESTful API experience or GraphQL proficiency. And if you've ever found yourself wondering what the actual difference is or, why developers seem to have such incredibly strong opinions about which one is better, well, this explainer is built specifically for you. We're going to demystify exactly what these terms mean so you can walk into your next interview or your next project planning meeting with total confidence.
Section 1. The API Waiter. How systems communicate.
Okay, let's dive into this by grounding ourselves in a super familiar concept. If you saw our previous explainer on APIs, you might remember that an API, an application programming interface, is essentially a messenger. It's like a waiter at a restaurant taking your order from the table back to the kitchen and then bringing your food back to you, right? When an app requests data, it needs a clear, consistent way to ask for things and get a predictable response. But here's the big secret. REST and GraphQL, they aren't completely different technologies trying to destroy each other. No way. They are literally just two different ways that waiter can take your order. They just represent two totally different philosophies for how that request and response conversation should actually go down.
Section 2. REST, the combo meal.
So REST has been the standard for decades, and it's still extremely widely used across the entire web. Think of REST like ordering a combo meal at a fast food joint. You walk up, you say, "I'll take combo number 4," and that combo, it comes with a burger, fries, and a drink. That is the whole package, and it is entirely predetermined. You can't exactly tell the cashier, "Hey, I just want the burger and like one sip of the drink, but hold the fries." Nope. You ordered combo 4, you get everything combo 4 includes. In REST, each endpoint, which is really just a specific address the API responds to, returns a fixed, predetermined structure of data every single time you make a request.
Now, the absolutely crucial point here is understanding the direct consequence of that combo meal approach. It leads to something developers call overfetching. Let's say you're building a screen on your app that just says, "Welcome back, Sarah." To get Sarah's name, you hit the user profile endpoint. But because it's a fixed REST endpoint, it doesn't just hand you her name. It hands you her name, her email address, her home address, her date of birth, her account creation date, the whole shebang. You only needed a first name, but you got this massive data dump. That is overfetching. You are literally wasting bandwidth and processing power downloading information that your app is just going to immediately throw away.
But wait, the rigidity of REST also creates the exact opposite problem: underfetching. This happens when that one rigid endpoint just isn't enough to get the job done. Imagine you need to show a user's name, but also their 5 most recent purchases. Well, the user profile endpoint doesn't include purchase history. So what happens? Your app has to make one trip to the server to get the user data, wait for it to come back, dig out the user ID, and then make a completely separate second trip to the server's orders endpoint just to get those purchases. You're forced to make multiple entirely separate trips to the server just to stitch together a single screen on your app. Kind of annoying, right?
Section 3. GraphQL, the buffet. So if REST is a fixed combo meal, GraphQL is like a massive, highly efficient buffet. You walk up to this buffet and you take exactly what you want. You want just the burger patty, a double portion of fries, and you want to completely skip the drink? Absolutely no problem. In GraphQL, instead of hitting a fixed endpoint that always returns the exact same shape of data, you send a highly specific query. You describe precisely the fields you want. It's one trip, exactly your order, nothing you didn't ask for, and absolutely nothing missing that you actually needed. It's a real game changer.
When we put these side by side, the contrast is pretty stark. On one side, we have REST, rigid, fixed, and highly predictable. It's simple. You hit a URL and you know exactly the shape of the data coming back. But on the other side, we have GraphQL, incredibly flexible, driven by custom queries, and offering super precise data retrieval. GraphQL was essentially invented to solve those exact overfetching and underfetching problems that REST really struggles with, especially as modern applications become larger, more complex, and way more data hungry.
Section 4. The social media test. Applying APIs in the real world.
Okay, let's make this totally concrete. Imagine you and I are building the next big social media app,
And right now, we are programming the user profile screen. We've got our design mockup, and we know exactly what data this specific screen requires to load properly. We need the user's name, their profile picture, their latest 3 posts, and their total follower count. That's it. Nothing more, nothing less. So how does our API waiter go to the kitchen and get this specific order?
Well, if we built our app using a traditional REST API, here's the crazy journey our app has to take. Step 1, we hit the user endpoint. This gives us the name and picture, but as we talked about, it probably also overfetches their email and bio, which we just ignore. Step 2, we take that user ID we just got and hit a separate posts endpoint to get their recent activity. Step 3, we make a third, entirely separate network request to the followers endpoint just to get that single number for the follower count. Guys, that is 3 separate trips across the network. If your user is on a spotty cellular connection on the subway, waiting for 3 sequential server requests to resolve before the screen even loads, that is going to make your app feel incredibly slow and clunky.
Now, let's look at the GraphQL alternative for that exact same screen. Instead of 3 exhausting trips, our app sends a single, neatly packaged query to the server. The query literally just says, hey server, please send back this user's name, their profile picture, exactly 3 of their latest posts, and their follower count. The server processes this one single request, gathers all the data from the database, and hands back one perfect, tailor-made package containing only those exact fields. Boom. We completely eliminated underfetching because we got it all in one trip, and we totally eliminated overfetching because the server didn't send us any useless background data. For mobile performance, that is a massive win.
Section 5. Trade-offs and the final verdict.
At this point, you're probably thinking, Cody, GraphQL sounds strictly better. It's faster, it's more efficient. Why on earth does anyone still use REST? Well, it all comes down to trade-offs, and one of the absolute biggest is caching. Caching essentially means storing a copy of a server's response so you don't have to do all the hard work of regenerating it every single time someone asks for it. Because REST endpoints are fixed and predictable. Remember, combo number 4 is always combo number 4. It is incredibly easy for servers and browsers to cache those responses. But GraphQL, it's like a custom order every single time. Because every query can be slightly different, caching a GraphQL response is notoriously tricky and requires a lot more engineering effort to get right.
So, summarizing the trade-offs, the distinctions are pretty clear. On the REST side, its greatest strength is its simplicity. It's easier to set up, caching is a total breeze, and because it's been around forever, the developer tooling and documentation practices are incredibly mature. It's absolutely fantastic for simpler apps with predictable data. GraphQL, however, offers that unmatched single request flexibility. But the cost of that flexibility is complexity. You have to define a really strict schema upfront, detailing exactly how all your data connects. Plus, there's always a risk of a client sending an insanely complex, deeply nested query that accidentally overloads your server. GraphQL really shines in complex ecosystems, especially where you have, say, web apps, iOS apps, and Android apps all needing slightly different slices of the exact same data.
So there you have it. REST versus GraphQL isn't actually a rivalry where one has to completely destroy the other. In fact, many large tech companies use both simultaneously, depending entirely on the specific microservice they're building. There's simply 2 different ways to place your order. The real question you have to ask yourself is, are you building a simple, fast-paced diner where the combo meal makes sense? Or are you building a massive, complex operation that requires the precision of the buffet? Think about your app's specific data needs, your team's expertise, and the network conditions of your users. Which API approach will power your next build? As client devices become more powerful, but data structures grow infinitely more complex, will the simplicity of REST eventually become a relic of the past? Or will the sheer complexity of maintaining GraphQL schemas push developers right back to the trusty combo meal? Something to think about. Thanks for hanging out, and I'll see you in the next explainer.